This video will help you fill out section 3, the bottom flap of section 3 in your Unit 9 Circles flipbook. The essential question is, what are the properties of angles with circles? On the top flap of this section, you went through the properties of line segments or segments with circles, a number of formulas that you need to know, and all you got to do is plug in the things you know and solve for the part you don't know. This section works the exact same way. So let's take a look at the properties of angles with circles. We've got three different options, class. We've got angles that are formed inside of circles, angles that are formed on circles, and the last section will be angles that are formed outside of circles. For this first example, angles inside circles are typically created by two chords. So if you would take your straight edge, let's go ahead and draw two chords. And it'd be good if you drew them so they don't actually intersect the center of the circle, because they don't have to be touching the center of the circle. And in fact, if we have chords touching the center of the circle, we know they're central angles. We already know the angle relationships there. So after you draw these two chords, class, I want you to label, let's go back, change that to green. Okay, I want you to label this drawing like this. I want you to label this as angle 1, and this as arc 2, and this as arc 3. So I'm going to make this simple. The number 1 represents this angle made by the two chords. This number 2 represents the measure of this arc between these two endpoints, and the 3 is the measure of the arc between these two endpoints. And here is our relationship of angles inside a circle. The measure of angle 1 is equal to 1/2 of these two arcs added together. Very simple. So the example would be if the measure of arc 2 is equal to 52 degrees and the measure of arc 3 is 46 degrees, what is the measure of angle 1? All we have to do is plug in the things we know in this formula. We're looking for the measure of angle 1, so we don't know that. Well, the measure of angle 1 is 1/2 of the measure of arc 2, which is 52 degrees, plus the measure of arc 3, which is 46 degrees. So let's use PEMDAS. We can solve the number in parentheses. 52 plus 46 is 98. And in your calculator, you can either type 1/2 in parentheses times 98, or you can do 98 divided by 2, same thing, and you'll end up with 48 degrees. So we're able to use the two arcs that are intercepted by these two chords, add them together and divide by 2, and you can find this measure of this angle. Now class, you should also know that the other side of this is a vertical angle. That means that's also 48 degrees. And if you want to know the measure of this angle, well, angle 1 plus this angle add up to 180 degrees, because these two angles are supplementary. So once you find one of these angles, you can find the other three very simply. All right, next example. What if the angle is on the circle? Usually we get angles on the circle when we are looking at a tangent and a secant, or also a tangent and a chord. Could be another reason why we would have this. Let's do a secant line, and we'll do a tangent line. Now class, I've told you that normally when I do tangents, I want to show you that it's tangent by plotting a point on the circle. So you can see it's only touching the circle at one point. Let's label this angle, this whole angle here, angle 1. Let's label this arc that's intercepting this, or intercepted by this angle, as arc 2. And our formula is this. The measure of angle 1 is equal to 1/2 of the measure of angle 2. It's actually the same property as inscribed angles. So here's our example. If the measure of arc 2 is 130 degrees, what is the measure of angle 1? Well, we don't know the measure of angle 1, so that remains a variable, equals 1/2 times the measure of arc 2, which is 130 degrees, 1/2 of 130 is 65 degrees. So the measure of this angle is 65 degrees. All right, our last situation, we just covered angles inside circles, angles on circles. Now our last scenario is angles outside of circles. There's 3 possible ways we can create those angles: with 2 secant lines, with a secant and a tangent, and with 2 tangents. So let's go ahead and diagram those 3 possible situations. First one, let's go ahead and create two secant lines. The next one, let's do a secant and a tangent. And the last situation, let's go ahead and draw 2 tangents. Notice that every one of these situations creates an angle that's outside of the circle. And the great part is it's the same formula for all 3. Let's follow my rule here real quick, class, that we want to show you in the diagram these are tangents by showing the point of tangency, where this tangent line is touching the circle. All right, here's our formula for angles outside of circles. The measure of angle 1, we have to label our values. This is going to be angle 1. Now class, usually when you label arc measures, you label outside of the circle. I'm going to label inside the circle just so we don't get those 2 numbers confused. And then arc 3 is this bigger one. Here's angle 1, arc 2, and arc 3. Here's angle 1, arc 2, and arc 3. And our formula is this. The measure of angle 1 is 1/2 of the measure of angle 3 minus the measure of angle 2. Now, we need to make sure you're aware, class, these have to be in the proper order. So you might want to make a little note here in your flip book. We've got some room above, or you should have some room. This is the bigger one. This is the bigger arc. This is the smaller arc. Now the smaller arc will always be the one closest to the outside angle. The bigger one will be the one farthest away. But if you just remember, this expression inside parentheses will never be 0. It's always the bigger one minus the smaller one. So here is our possible example. If the measure of arc 2 is 26 degrees and the measure of arc 3 is 198 degrees, what is the measure of angle 1? Let's go ahead and solve this. We want to know the measure of angle 1, and we know that's an outside angle. That's going to be 1/2 of the measure of arc 3, which is 198, minus the measure of arc 2, which is 26. Let's do PEMDAS. We'll do our parentheses first. 198 minus 26 is 172. And calculator, 1/2 of 172 is 86 degrees. And this will apply, class, whether you have 2 secants, a secant and a tangent, and 2 tangents. So when you're working on these problems in your assignments, look at what types of line segments are making the outside angle or the inside angle or the angle on the circle. Apply the formula, plug in the things you know, solve for the thing you do not know. So there is our video on the properties of angles with circles.